Now let's look at an industrial example where the part of the propylene glycol production system, where in the reactor we have this propylene oxide plus water. These two reactants are coming. The product from the reactor is the propylene glycol. Now the reaction being exothermic, we need a cooling system for the reactor, which is done typically using water. So water goes through the jacket of the reactor and then maintains the temperature. Now at around near ambient temperature, the conversion of propylene oxide is around 95%. But because of this high volatility of this propylene oxide, there are much excess water to be put in the reactor system. So that's why the product from the reactor contains propylene glycol, propylene oxide plus excess water. And this comes to the distillation column. Now in the distillation column, the propylene oxide, remaining excess water, and a little of the glycol goes to the top product, but mostly the glycol is separated as the bottom product. Now you can think about, for this simple part of this industrial problem, lots of control can be applied. Now this configuration, a reactor followed by distillation column, it's a common scenario in many chemical process industries. Now look at this problem that we need to maintain a certain product composition at the bottom so that the glycols are recovered as product, and also have to have some top composition there which needs to be maintained, and here the temperature inside the reactor needs to maintain. That is one of the main aspect, that the temperature should be maintained. That's not only from a safety perspective, also from the product optimization perspective. So temperature, pressure, flow rate, level, composition, all of this can be considered to be separate control problem. But do remember that all of this one will affect another. So if you have something with the flow rate of the cooling water, that will make a change in the temperature, and with the change in the temperature, there will be change in the conversion into glycol, and the conversion to glycol, this composition here out of the reactor will change, and then that will affect the distillation column operation. So now from this entire system, you need to define what is the control objective for certain parts and how to maintain those control objectives. Now this is another example that I will often refer to. So you have a good understanding of the process from the control perspective, and then whenever I refer it as this reactor plus distillation column problem, you should be able to think about that what problem I am talking about and relate it to from the control perspective.